Hey everybody, this is Justin Rush, and today I'll be talking about Lab 1. So in Lab 1, our objective is to calculate the total charge necessary to float one tape above another. And to calculate this, we use several fundamental principles that I'll explain in more detail in the next slide. And the result I found at the end of this lab was that the necessary charge of that allowed this to happen is 5.974 times 10 to the negative 9 coulombs. Here's a more detailed look on the disciplines. So the Coulomb law is very important because it calculates electric force, and we know that F equals 1 over 4 pi epsilon Q squared over R squared. And this Q is what we're looking for. Now, the momentum principle states that if an object is in equilibrium, then the components of the force equal each other. In this case, it will be gravitational force, which equals to mass times gravity, and then electric force. And then Newton's third law is every force has an equal and opposite reaction. Initial observations that I have found was that two U-tapes will repel each other due to light charges. This makes sense because they came from same sources. Neutral objects such as hands, pens, and books will attract U-tapes. This also makes sense because they did not come from the same sources. It's commonly known fact that a cotton ball rubbed in hair creates a negatively charged cotton ball. So the fact that the U-tapes attract to that negatively charged cotton ball deducts that the U-tape is positively charged. Now the diagram on your left side is the diagram that I took off of Lab 1 instructions. This is the current system that we're working on, and this sets the scene for our experiment. As you can see on tape B, there's two force exerting on it. There's electric force and there's gravitational force due to A. Electric force created due to A, and then gravitational force created by its own mass. Before we get into data, there's some assumptions to make the data simpler and able for us to calculate. Number one is treating the tape as a point charge. This allows us to use Coulomb's law, which I explained earlier. And then number two is assume that all U-tapes have an evenly distributed charge along the length of the tape. Now, first thing we had to calculate to reach our objective is the gravitational force. And we know that is mass times gravity. We are given that 1 gram per meter, that a tape has 1 gram per meter, and the length of tape I'm using is 0.2032 meters. So the mass of that tape is 0.2032 grams. So we times that by not the gravity, and we got approximately 0.002 newtons. Now we have the gravitational force. So we plug that into our Coulomb's law and then solve for Q. And as you can take a look on the bottom of the screen. And this is my code that correctly describes what we're calculating. As you can see, there's electric force and there's also gravitational force. And here's the output of that code, and it shows correctly the diagram that the free-flowing force diagram on the previous slide, and also detects the correct amount of charge required for the tape to float above another one. Now the answer to this question is that the observation wouldn't really change. The only thing that would be different is that the U-tape is negatively charged instead of positively, and it will still be attracted to neutral objects, and they will still repel each other. Now, the reason why we try to eliminate contact as least as possible is that it yields better results for our objective, and the U-tapes won't become as neutral by contact with our hands. We learned that charged objects can be attracted to neutral objects, and we understood how to use fundamental principles to calculate to reach our objective.